So remember, we're dealing with rational expressions, and when you hear the word rational, what word do you think of? Fraction, thank you, yes. Okay, so they're like algebraic fractions. So we talked about how to reduce them. Okay, much like way back when you started fractions, that's one of the things you learned how to do. Something new we have to do with these is we have to state non-permissible values. And now what we're going to look at today is how to multiply and divide them. So just to start, okay, and we're asked to multiply all of these and state any non-permissible values. Well, the first one is just like a review. Okay, there's no non-permissible values because there's no variables. When you multiply, what would you do before you multiply? Yeah, you would want to try and reduce fractions if you could. And remember, you can reduce any numerator with any denominator. We don't have to be in the same fraction. So is there a pair of numbers, one in the numerator and one in the denominator, that I could reduce? 5 and 15, I could divide each by 5. 1, 3. 2 and 6, I can divide each by 2. 1, 3 again. So now I'm left with 1 times 1 over 3 times 3. Same idea when we introduce variables. Okay? Before you reduce, state any non-permissible values. What can't X and Y be? What would make the fractions undefined for X and Y? Sorry? 0. Because as soon as a 0 goes in for X or Y, can't divide by 0. So I'm going to rewrite this just to give myself a little bit more space because I'm going to have to do some reducing. Okay. Look at all the numbers first. Is there a pair of numbers, one in the numerator and one in the denominator, that I could reduce? 4 and 8. I could divide each by 4. Now, the x's. How many x's are getting multiplied up top? How many x's do you see getting multiplied up top? 2. Here. How many x's are getting multiplied on the bottom? 2 again. So don't they cancel each other out? It all becomes 1. Because if you've got an x times x up top and an x times x on the bottom, it doesn't matter what order they're in because everything's getting multiplied. You can reduce them. How about the y's?
Why is it 8 like 4 and 8? Why isn't it 8? 2?
Oh, sorry, should be 2. What about the y's? How many y's could I reduce? 1, right? Because it's always the less of the 2. There's 2 up here, there's 1 down here, which means the most I can divide is y. So y divide y is 1. Y squared divide y is y. So now I am left with 1 times 1 times y, which is just plain old y. And on the bottom, I'm left with 3 times 1 times 1 times 2 times 1, which is 6. That's it. Question? Sure. Okay. Now we're going to get a little bit more complicated. Okay. It's hard to see what to reduce. It's actually hard to see too what the non-permissible values are. So when you get questions like this, you have to factor to find the non-permissible values and to reduce. So we need to factor, we can actually factor both the denominators and both the numerators. This is a trinomial. So it's going to go to two binomials. X and X. I'm looking for two numbers that add to -1, multiply to -12. 3 -1. How about the bottom? What kind of factoring is that? Isn't that a difference of squares?
Plus 9.
Yeah. So X plus 3, X minus 3. Second numerator is another trinomial. This time I'm looking for two numbers that add to -4 but multiply to +3. -3, -1. Watch out for the bottom, or the last one. It's close to a difference of squares, but it's not. Because nothing times itself gives you 4x. So what kind of factoring? GCF. And what is the greatest common factor? X, which means what's left? X minus 4. Now remember, before you reduce, state the non-permissible values. All the values of X that would make the denominator 0. So just go through all the factors. What would make this 0? That's an NPV. What would make this 0? That's another one. What would make this 0? 0. What would make this 0? So those are all the NPVs. Now we go to town. Any numerator with any denominator that are identical. Those cancel each other out for 1. Do you see another pair? X minus 3s. Do you see another pair? X minus 4s. And that's as far as I can go. So what's left up top? X minus 1. You don't have to put parentheses around it, but I'm going to anyway. And the only thing left in the denominator is X. You guys try D. At least see if you can factor everything you can. So, if you factor everything correctly, you should get down to that. So you can factor 3 of the numerators and denominators. Remember, don't cancel them. What are the NPVs? This one, -1, +1. What value of A would make this 0? 0. 5 minus 0 is 0. 5. So the NPVs are -1, +1, and +5. Now remember, when you have an expression by itself like this, it's got two terms in it, think of it like it's got parentheses around it. Makes it easier to reduce. Speaking of which, what could I reduce? A minus 1. Divide each of those and get down to 1. Right. What do these, whoa. What do these reduce to? No. We talked about this special case. When they're reversed, they reduce to -1 when they're reversed. And it doesn't matter where you put the -1. You could put it up here, you could put it down here. I usually just put it up top. Okay? There's nothing else to reduce. So we're ready to write our answer. Notice I've got a plus 5 times -1 times a. The proper order we should write that is the -1 times a plus 5. That's the way it should be written. Negative first, then the monomial a, then the binomial. On the bottom, it's easy, it's a plus 1. And again, you don't need parentheses on the bottom, but you do need parentheses here to separate it from the a. This is really important. Don't multiply through. Some of you might be tempted to say, okay, I got to multiply -a by a plus 5. You don't have to. Because remember, in order to simplify things, we want it in factored form. So we leave it in factored form. Okay? So whatever you do when you get a final answer, don't multiply through. You're just wasting time and chances of making a mistake. Okay? So you don't want to do that. Okay. Dividing. How do we divide fractions? We change it to a multiplication, but we have to flip the second fraction or take its reciprocal. So just as a review with all numbers, 5/3 divide 1/6 would be the same as 5/3 times 6/1. And now it's like the question on the previous page. What can I reduce? There's no non-permissible values, by the way. 3 and 6 can go down to 1 and 2. So I'm left with 5 times 2 over 1 times 1, which simplifies further to 10. This one, variables but not factor. So I don't have to factor anything yet. So what are the NPVs? What can't y be? 0. Change it to multiplication. 3x squared over y squared times the reciprocal of the second fraction, which is x over y. Notice I got a new variable in the denominator. What's the NPV for this one? Still 0, right? So I'm good here. Now, what can I reduce? I can divide by a y, and I'm left with 1 and y. Sorry. I can divide by an x, and left with x up top and 1 here. So I'm left with 3 times x times 1, which is 3x, over y times 1, which is just plain old y. And we're done. Now we get to the more complicated ones. First thing I'm going to do, well, you have a choice. You can factor everything first, or you can change it to multiplication first. Okay? I'm going to factor everything first, because I've got to state the NPVs. How would I factor this? First numerator. X, and then I heard 2. X. Say it as quiet as you can. Denominator? I heard a faint X. Oh, I heard GCF louder. So I'm left with X times. Good. Divide. Not 5. Because that will give us a sum of 1. X plus 3 and x minus 2. And on the bottom, good. Now, state your NPVs. What would they be? 0, 4, minus 5, and 4 again, but we don't have to write it twice. Now let's change it to multiplication to get ready to reduce. But before you reduce, notice when we flip the second fraction, we got some new factors in the denominator. You have to state the NPVs on these as well after you flip. So what can't x be? So we got to add that to the list. And 2. So remember, after you flip, factor first, state your NPVs, flip, add to your NPVs if you need to. Now go to town. What could I reduce? Sorry? X minus 4. Anything else? X minus 2. Good. And that's, looks like it's it. So up top, I'm left with the factor x plus 2 times x plus 5 And on the bottom, I am left with x times x plus 3. And remember, don't multiply through. Leave it. Stop. You guys try the next one. Anybody like to take issue with me on anything?
Wouldn't the P minus one be positive?
Yep. Now NPVs. -7, +7, 0. We don't need to write -7 again.
Okay.
And now we've got to change it to multiplication. For any new NPVs created, -1. Just draw an arrow to show you where it came from. Now we've got +7s. We've got -7s. We've got +1s. And I think that's it. So we should end up with P over P plus 7. So remember, it's really important to state NPVs after you factor, because if you reduce and then try, you're going to miss a whole bunch of them. Okay? Just keep that in mind. So you can see these questions can get a little bit crazy. I mean, these are like 4 and 5 mark questions, because you're having to do a lot of factoring. Like here, you've got to be able to factor 4 things. You've got to be able to state NPVs. You've got to be able to change the multiplication and reduce. That's a lot of marks. That's a lot of steps.